Everyone, Assalamu alaikum. Today we are attending here to present our research work, that is pothole, speed breaker and vehicle detection using YOLO V5, a real-time object detection. Here is the list of our group members. I am Atiya Aisha Prema. My ID is 160015042, Department of CSC in Prime Asia University, and my one and only group member, Shubham.
First of all, we wish to express our sincere thanks and gratitude to our supervisor Anika Rahman ma'am, lecturer at Department of CSC, for the continuous support during our thesis study and related research, for her patience, motivations and immense knowledge. Her guidance helped us in all the time of research and writing the thesis. Here are the spotlights of our thesis work. We can see that is overview, objective, understanding the problems, a brief story of object detection, an overview of the YOLO architecture, methodology, implementation, results and conclusion. Now I will describe the part of overview. So potholes are not only a source of frustration to drivers but also negatively impact the economy due to damage to vehicle and costly road repairs. To improve the efficiency of maintenance and reduce the cost thereof, this paper proposes a vehicle-based computer vision approach to identify and analyze potholes, vehicles and speed breaker using a car-mounted camera. The comes about will then be locked in conjunction with the GPS facilities of the pothole or speed breaker for utilized by specialists and maintenance agencies and to help other drivers. Drivers will promptly get a caution notice to require prompt activity in case potholes or speed breakers are identified in real time. In the next, I will describe the objective. Recognizing potholes precisely and rapidly is one of the critical assignments for deciding appropriate procedures in street support offices. So, detecting potholes accurately and quickly, detect objects using simple image processing methods, alert the driver to take immediate action. Next, I will describe the understanding the problems. A pothole is a hole in a road surface that results from gradual damage caused by traffic and bad weather. Potholes are areas of road surface that have cracked, worn away, and eventually formed a hole. The friction between the tires and the road surface heats up and causes the road to expand. This expansion results in the formation of cracks in the roadway surface over time. Potholes make a ride bumpy that can be risky. Potholes can be generate damage such as flat tire and wheel damage, impact and damage of lower vehicle collision, cause alignment issues and causes major accidents. Thus, accurately and quickly detecting potholes is one of the implement tasks for determining proper strategies in road maintenance agencies. Next, we can see a figure of object recognition. Now I will describe the object recognition in computer vision. Object recognition is a general term to describe a collection of related computer vision tasks that involve identifying objects in digital photographs. Detecting objects in digital image has become one of the most important applications for industrial use to ease user and save time. This technique has been developed years ago, but improvement of it is still required in order to achieve the targeted objective in more efficient and accurately. Image classification involves predicting the class of one object in an image. Object detection combines the two tasks and localizes and classifies one or more objects in an image. Next, we can see that a brief story of object detection. A modern detector is usually composed of two parts. One of is backbone and another is head. Now, I will describe what is head in a brief story of object detection. A backbone which is pre-trained on ImageNet and a head which is used to predict classes and bounding boxes of objects. For those detectors running on GPU platform, their backbone could be BGG, ResNet, ResNext, or DenseNet. For those detectors running on CPU platform, their backbone could be SqueezeNet, MobileNet, or ShuffleNet. Next, I will describe the two stages in a brief history of object detection. We already know that on-off is one stage object detector. So it is the most representative models such as SSD, RetinaNet, and YOLO family. YOLO family consists of 5 members: YOLO V1, V2, V3, V4, and YOLO V5. And the most representative two-stage object detector is the RCNN series, including fast RCNN, faster RCNN, RFCN, and Libra RCNN. So I would like to request my teammate to describe his slide. Thank you.
Thank you, Prema, for giving me the opportunity to speak. Let me introduce myself. My name is Shubham Rong. I'm from batch 163, Department of Computer Science and Engineering.
Hello faculties, on behalf of our thesis presentation, I would like to welcome you. It is very nice to be here today. Okay, let's start by looking at the rest of our spotlight, which is an overview of the YOLO architecture, methodology, implementation, results, and conclusion. An overview of YOLO architecture. The YOLO model was first described by Joseph Redmond in 2015, paper titled with "You Only Look Once: Unified Real-Time Object Detection." Rosgarsik, developer of RCNN, was also an author and contributor of this work. The approach involves a single neural network trained end-to-end that takes a photograph as input and predicts bounding boxes and class levels for each bounding box directly. The technique offers lower predictive accuracy that's operate at 45 frames per second and up to 155 frames per second for a speed-optimized version of the model. The model works by first splitting the input image into a grid of cells, where each cell is responsible for predicting a bounding box. If the center of bounding box falls within the cell, each grid cell predict a bounding box involving the XY coordinate and the width and height. The YOLO network consists of 3 main pieces: backbone, neck, and head. Backbone, a convolutional neural network that aggregates and forms image features at different granularities. Neck, a series of layers to mix and combine image features to pass them forward to prediction. Head, consumes feature from the neck and text box and class prediction steps. And here is a graph of YOLO version 5 benchmark comparison. Methodology. Our working methodology consists of 5 different divisions. First, read the input images. Second, extract images. Third, improve segment. Fourth, apply Gini filters. 5, dilate the image 5 times. 6, detect contour. To detect our desired object in our working methodology, we took 4 different models, that is, road model, pothole model, vehicle model, and split breaker model. Implementation. YOLO version 5 implementation part consists of 6 different steps. First, preparing the dataset. Second, environment setup. Third, files or directories configuration. Fourth, training the dataset. 5, interference the trained dataset. 6, result visualization. Now let's have a look at the visualized result of our thesis work. Our visualized result in a graph set. Here is the visualization of confusion matrix, visualization of F1 curve and P curve, visualization of PR curve and R curve. Conclusion. We presented a good preliminary method for pothole, vehicle, and split breaker detection system, which is designed to collect route images through a newly developed optical device mounted on a vehicle that detects pothole from the collected data using our proposed algorithm. The device collects potholes, vehicles, split breaker data, and then the collected data is sent to our proposed algorithm.
The device was designed to be easily mounted in a vehicle, and it will have several functions such as collecting and storing data of our potholes and speed breakers, communicating by a GSM or Wi-Fi module, and gathering location information by a GPS. References that we used in our thesis work. Thank you, faculties, and thank you everyone.